Worst volcano Armageddon of human history. The most recent Toba eruption took place in the location of the present-day Lake Toba in Sumatra, Indonesia, some 74,000 years ago. One of the greatest explosive eruptions on record for the planet. According to the Toba catastrophe idea, this event resulted in a worldwide volcanic winter lasting 6 to 10 years and maybe a cold period lasting 1,000 years. The Youngest Toba eruption is the most extensively researched supervolcanic eruption. In this video, we'll be exploring every detail about it. Stick with us till the end of the video, cause we've got a lot of mind-blowing information for you. The supervolcanic eruption. According to potassium-argon dating, the most recent Toba eruption took place near the current site of Lake Toba in Indonesia around 74,000 years ago. This eruption, which occurred during the Quaternary period and was the final and greatest of the 4 eruptions of Toba caldera complex. It is also identifiable by its characteristic horizon of ashfall, the Youngest Toba tuff. It produced a significant contribution to the 100 km by 35 km caldera complex and was predicted to have a volcanic explosivity index of 8, the highest rating on the scale. Dense rock equivalent estimations of the eruption's eruptive volume range from 2,000 km cubed to 3,000 km cubed. The most popular DRE estimate is 2,800 km cubed of about 1,115 kg of erupted magma, of which 800 km cubed was deposited as ashfall. The erupted mass was at the absolute least 12 times larger than the 1815 Mount Tambora eruption in Indonesia, which was the biggest volcanic eruption in the recent memory and resulted in the 1816 year without a summer in the northern hemisphere. Overall of South Asia, the ash layer left by Toba's eruption was around 15 centimeters deep. Additionally, the Indian Ocean, the Arabian Sea and the South China Sea were covered in a layer of volcanic ash. Deep sea cores recovered from the South China Sea have increased the known range of the eruption, indicating that the estimated erupted mass of 2,800 km cubed is either an underestimate or a minimal value. The Toba caldera complex may have erupted up to 13,200 km cubed of total bulk volume. According to recent approaches, computational ash dispersal model employing a 3D time-dependent tephra dispersion model, a set of wind fields, and many tens of thickness measurements of the YTT tephra deposit. Due of this, the Youngest Toba eruption has been referred to as VEI-9 event by certain publications. Models for global cooling and volcanic winter. Michael R. Rampino, a geologist, and Stephen Self, a volcanologist, contend that the eruption resulted in a short dramatic cooling or volcanic winter, which produced a 3 to 5 decrease in Celsius in the world's mean surface temperature. Following the eruption, there was a 1,000-year period of low 18 degrees and increased dust deposition, according to evidence from Greenland ice cores. This stadial of colder temperatures lasting 1,000 years may have been brought on by the eruption, with the persistence of the Toba stratospheric loading being responsible for 2 centuries of it. The Youngest Toba tuff may have supplied the additional push that led to the climate system to flip from warm to cold states. According to Rampino and Self, who think that global cooling was already occurring at the time of the eruption, but that it was a sluggish process. Clive Oppenheimer acknowledges that the eruption may have caused a millennium of chilly temperature prior to the 19th Dansgaard Osgera event. Even he disputes the theory that it caused the last glacial event. Scientists concur that a supervolcanic eruption of the magnitude at the Toba caldera complex must have resulted in very widespread ashfall, strata and injection of toxic gases into the atmosphere. With impacts on weather and climate on a global scale, there is disagreement about whether the eruption was the direct cause of the 1,000-year cold spell in Greenland or the last glacier, despite the fact that the sudden climactic shift documented in the Greenland ice core data occurs around this time. Physical data against the winter hypothesis. Archaeologists led by Christine Lane reported discovering a microscopic layer of glassy volcanic ash in Lake Malawi sediments in 2013. They were able to link the ash to the 75,000-year-old eruption at the Toba caldera complex, but they were unable to detect any changes in the types of nearby fossils, which they would have anticipated following a harsh volcanic winter. Richard Roberts criticized them for their finding that the eruption had no impact on East Africa's climate. Lane clarified, sub-decadal resolution was achieved by looking at smear slides at 2mm intervals, and subannual resolution was achieved by using X-ray fluorescence scans at 200 micrometer intervals. We found no noticeable change in the FETI ratio or sediment composition, indicating that there was no thermally induced overturn of the water column after the Toba super eruption in 2015. A fresh investigation of the climate in East Africa confirmed Lane's finding that Mount Toba was not significantly connected with cooling. There was no sign of volcanic winter according to a 2018 analysis by Chad Yost and colleagues of cores from Lake Malawi, dating to the time of the Youngest Toba eruption. They contended that there was no impact on African people. According to John Hawkes, the finding supports the data from other studies that show the eruption had no significant impact on the climate or the population of humans. Genetic bottleneck hypothesis. A genetic bottleneck in human evolution has been connected to the Youngest Toba eruption, which is thought to have occurred about 70,000 years ago. Because of the eruption's impact on the climate, it's also thought that the number of the entire human population was drastically reduced. The genetic bottleneck hypothesis states that between 50 and 100,000 years ago, human numbers drastically declined, with just 3 to 10,000 people remaining. The theory that modern humans are derived from a relatively small population of 1,000 to 10,000 breeding couples that lived about 70,000 years ago is supported by certain genetic data. The Youngest Toba eruption is said to have caused a worldwide ecological catastrophe, including the loss of flora and a severe drought in the tropical rainforest belt in monsoon areas. According to proponents of the genetic bottleneck hypothesis, the eruption might have generated a 10-year volcanic winter that would have severely reduced populations and entirely limited human food supplies. In many species, including hominids, these environmental shifts may have caused population bottlenecks, which may have promoted divergence within the reduced human population. Therefore, rather than progressive divergence over hundreds and thousands of years, the genetic distinctions among contemporary humans may represent changes within the past 70,000 years. A connection between Toba caldera complex and a genetic bottleneck has been questioned by other studies. For instance, in southern India, ancient stone tools were discovered above and below a heavy layer of ash from the Youngest Toba eruption, and they were very identical throughout both strata, indicating that the local people was not wiped out by the eruption dust clouds. The authors of the study draw the conclusion that many species of life survived the super eruption, contrary to prior research which has revealed substantial animal extinctions and genetic bottlenecks. After examining more archaeological data from the southern and northern India, the Toba eruption may have compelled humans to adopt novel adaptive methods which may have enabled them to displace Neanderthals and other archaic human species, according to data from pollen analysis and theories put forward by certain scholars. The estimation of the eruption's effects on local and global climate is challenging, and there is conflicted evidence for the eruption that occurred before the bottleneck. The entire human genome sequences have also undergone genetic analysis, revealing that the effective human population size at 1.2 million years ago was less than 26,000. Repeated population bottlenecks or periodic replacement by rival Homo subspecies are two possibilities for explaining this low population size of human ancestors. Evidence suggests that some species experience genetic bottlenecks after the Youngest Toba eruption. The population of the chimpanzees in eastern Africa, orangutans in Borneo, cheetahs and tigers all increased from extremely low numbers between 70,000 and 55,000 years ago. Migration after Toba. Anatomically modern human species' precise geographic distribution at the time of the eruption is unknown, and it's possible that any people that survived resided in Africa before migrating to other continents. According to estimates based on mitochondrial DNA analysis, the main African migration took place between 60 to 70,000 years ago. This dates the Youngest Toba eruption to around 75,000 years ago. And that's it for the video. Thanks for watching, and please make sure to like and subscribe, we really appreciate it. We'd also like to know your thoughts and feelings about this volcanic experience, so feel free to drop comments in the box provided.